All right. This is the one we finished with yesterday. Did you guys have any questions about this one? 5, 6, 7, 8, 9. You did it yesterday at the end of the period. Do we have any questions on that one? No? We're good? So, yesterday you started this in your groups in class, and then you had the pet store problem, and then the lasso problem, and then the temperature problem. Okay, so how high off the ground were Sam and Dan when they got onto the Ferris wheel? 10. So 50 is the midline. The amplitude is 40. So if we do the midline minus 40, then we get the low point, which is 10. How high off the ground do they get? 90. So that's the midline plus the amplitude. So 90. Oh. All right. How long does it take them to do one complete rotation? 40 seconds. Was it 40? 2 pi divided by pi? Yes, it was 40. So basically here in number 7, they're asking what the period of the graph is, because in the Ferris wheel problems, one rotation is the period of the graph. And so the math that you would do on that one is 2 pi divided by pi over 20. And we do the keep it, change it, flip it. And so that's where we got 40 seconds. And so the answer to number 7 helps you answer number 8. So if you've been going for 160 seconds, how many full rotations is that? 4, because 160 divided by 40 is 4 rotations. Okay. What does the amplitude represent in the context of the problem? The radius of the wheel. You could also say from the middle height how much you go up to the top height and how much you go down to the bottom height. So you could say it's like the middle of your height, something like that would be fine. So it's on either one. Yeah. So there's a couple different interpretations of how you could look at that. So yes, but it is definitely the radius of the Ferris wheel. What is the period representing in the problem? Yeah, how long it takes to do one full rotation. Okay. This next one, I think of the homework problems I gave you, I think this one is the hardest one. And the reason I think it's the hardest one is because this graph does not start at 0. Did you guys see that? Mm-hmm. It starts to the right 3. It doesn't start at 0, okay? But if you look at this, it still looks like an upside down coast graph. You guys notice that? It's just an upside down coast graph that has been shifted to the right. All right, so we still want to figure out what the highest point is. We still want to figure out what the lowest point is. We still want the midline. All the stuff we normally want, we're still trying to find, okay? So if we look at this one, I can see that the very lowest point is right here. And what value is that at? 2. That's at 2. And I can see the very highest point is right here. And what value is that at? 32. And so what's the distance between 2 and 32? That's a distance of 30. So if you have a whole distance of 30, what's the amplitude? 15. So 15 above the middle, 15 below the middle. Okay, so if our amplitude is 15, what does that mean for the midline? 17, because we take 2 and we go up 15 from that, so that's 18 right there. Here's our midline right here at 17. Okay. So the midline is 17, the amplitude is 15.
I have a question. On the please understand, if we have a graph like that, do you want us to like draw the lines and put the numbers of the amplitude?
I'm doing this mostly just because it helps us relate it back to the Ferris wheel problem, and we feel a little bit more comfortable with those, so anything I can do to remind me of those is usually good. Is it necessary to show? No, you could probably do it without showing your work on those. Yeah. All right, what is the period? So I can see when I say the period of the graph, I want to see the starting point and when it does a full rotation and gets back to that same starting point. And they were nice on here. They kind of labeled them for you. So we've got it right there, and we've got it over here. And so what do you see? Starts at 3, goes to 31. And so the period of the graph is 28, okay? So I'm going to say the period of the graph is 28. What is the horizontal shift? 3. Is it to the right or left? Right. Okay, so I'm going to say right 3. So all these questions were helping you look at the picture and find all the important information so that you could write the equation. That's what all those questions were doing. Now, before we actually write the equation, we do have to find the b value. So we know that the period results in being 28, but we don't know what the b value is. So I'm going to say 2 pi divided by b equals 28. And then what do I do? Multiply by b on each side. So 2 pi equals 28b. Divide by 28, so I have 2 pi over 28 equals b. And can we simplify that? Yeah, pi over 14. Okay. So now we can write the equation. What should we write? T minus 3, yep. You're very close. Plus 17. Good. So we have, it's an upside down coast graph, which is why we have the negative. The 15 is the amplitude we found. The 17 is the midline we found. We put the b value in front of the t, but we made sure to put parentheses around this because we had a shift to the right of 3, so we had to put t minus 3. Okay. The reason we put this in parentheses is because the minus 3, that part, has to be when the t is alone. It can't be when the t has a coefficient. Okay. All right, so how many gerbils will there be on the 78th day? You got to plug in 78, right? Okay, and we got 24? 24 point something, and we'll round down because part of a gerbil is sadistic and inappropriate. 23 point something, round up? Okay, that's fine. All right, let's go ahead and turn the page. Did you guys like the picture I found of a dude with a lasso? He's real creepy. So when you look at somebody spinning a lasso, now I'm going to be honest, I am not from a place where people spin lassos. Do you really? I wish I could say I'm surprised, but I'm not. I'm not at all surprised. Of course. That would be a reasonable thing to do when you show horses, is spin lassos. But apparently when you spin a lasso, it goes up and down in the air. Yeah, but it goes up and down in the air, right? Okay, so this problem is referring to the fact that when you spin the lasso, it goes up and down in the air. That's what it's talking about. And so that's what's making that like up and down movement, is that the lasso is like starting down and it's going up and then it's coming back down again, apparently. Because you're a lasso expert for us. All right, so what was the highest point reached by the knot? It'd be 6.5, yeah. So 3.5 is the midline. If you add the amplitude to the midline, you get 6.5. So that would be the highest point. What's the lowest point? 0.5, because you have 3.5 minus 3. What is the period? How do we find it? So 2 pi divided by 5 pi thirds. Are we all doing the problem right now? Yeah? So this would be 6 over 5. So 1.2 is the decimal. Now, what does that 1.2 represent in the problem? The time it took for what? For the lasso to start at the bottom, get to the top, come back to the bottom again. Now, I know that it's starting at the bottom because this is a negative coast graph, and negative coast graphs start at the bottom, right? So I know that's how they're measuring the period. From the low point of the lasso to when it comes up in the air to when it goes back down again to its lowest point. Okay. What will the height of the knot be after 25 seconds? What do we got to do? Plug in 20 feet. So many of you guys are eating right now. It's cracking me up because you guys are like wanting to answer, but you're having to cover your mouths. All right. So these questions were okay? We were good with these ones? Okay. So the types of questions you can expect to answer on something like this is just understanding that we have a midline and that to calculate our highest number and our lowest number, we just need to add or subtract the amplitude from that number. Okay, so those questions are pretty easy. Finding the period, again, it often involves a keep change flip. That's very common. I would say maybe the hardest questions might be interpreting what the period means. I think sometimes interpreting what it really is talking about for the problem can be the hardest part. Okay, so this one is talking about the average high temperatures for a specific town. So you know how when you look at the temperature for the day, it gives you the high and it gives you the low temperature? So they're saying they took the data and they only looked at the high temperature for the given time interval. They weren't looking at the lows that were projected, they were just looking at the highs. So if you look at this, what's the higher end of the average high temperature? 85, and then what's the lower end? 35, okay. And that kind of fits because if we're thinking about winter days, then 35 might be the high for the day. And if we're thinking about like spring days or like summer days not in the south, then 85 might be the high for the day, so that seems kind of reasonable. What's the period of the function? 12, what do you think that 12 is representing? Yeah, 12 months in a year. So it's talking about the average temperature over the course of the year. Okay. All right, so that needs to be turned in.